All right, today we're figuring out how you can literally store energy inside an invisible electric field. Yep, it all comes down to storing electrical energy and then releasing it instantly. So how does that work? Okay, think about it like this. Potential energy is just stored energy. And guess what? Electricity works the same way. So you have gravity acting on mass and the Coulomb force on charge. But here's the key. They're both conservative forces. That stored work, we call it electrostatic potential energy, and it only cares about where you start and finish. So potential isn't about the charge, but the energy at a specific location, kind of like an energy map for the field. So how do we actually build a device to hold this energy? We need an energy bucket. Enter the capacitor. Its whole job is to hold a charge, and by doing that, store energy in the field between its plates. We start with neutral plates. Then we move charge from one to the other, building up that energy-storing field. And what's really wild is that its storage ability, its capacitance, depends only on its physical design. But get this, a 1 farad capacitor would be huge, like the size of a small city. That's why we use microfarads. So how can we pack more energy in without making it huge? The secret is in the gap between the plates. This is our secret weapon, a dielectric. Putting this insulator between the plates is a total game changer for the field. Okay, so the main field makes the dielectric's molecules line up, creating their own tiny opposing electric fields. And this is the key point. This polarization creates a field that pushes back, reducing the net field inside. With a weaker field, you can pile on way more charge for the same voltage, and that means a huge boost in capacitance. Okay, so the capacitor stores energy, but where is it? In the plates? The charge? The answer is actually pretty cool. This little formula tells us everything. The energy isn't in the stuff, it's in the field itself. That's right, the energy is stored in the empty space. An electric field isn't just a force, it's a container for energy. And this matters because capacitors are literally everywhere, in your phone, your computer, and yep, that camera flash. So if energy is just sitting in fields, what else could we do with all the invisible fields that surround us every day?